viewers, in this lecture I'll be teaching you about the geometrical information of molecules that can help us understand the composition, properties and the structure of that molecule. First of all, we know that before starting we should have a molecule to discuss. So the name of that molecule would be required. After that, central atom. After that, substance. Then atomic number, electronic configuration. After that, excited. Now we know that there are two types of electronic configuration. The second one is mostly known as hybridization, but here we will be discussing about the excited one. According to Hund's rule, there would be electronic configuration, but at the second condition like boron and berylium, so for that we will be having excited electronic configuration too. After that, number of active set, nature of active set, then hybrid orbital, geometrical shape of that molecule, and repulsion. Of course, angle between the molecule. That will help us to understand that whether there is a lone pair or not. First of all, that molecule is berylium chloride. The central atom is berylium because of less contribution. The substance is 1 berylium because we know that less contribution, 1 berylium is being used. Atomic number is 4. Electronic configuration is 1s2, 2s2 according to Hund's rule. But we know that the electronic configuration of beryllium, boron and chloride is much different. According to Hund's rule, there is different configuration, but in the real life there is different compositions. So for the configuration of the carbon, boron and beryllium, we use another form that is called excited configuration. So according to excited configuration, its configuration is 1s2, 2s2 and 2px. After that, number of active set is 2. Now the nature of that active set is bond pair, there is no lone pair. Hybrid orbital is sp. It is in linear shape. The repulsion is bond-bond repulsion, and the angle between the molecule is 180. That was all about the berylium chloride. Now let's move on to the boron trifluorine. Boron trifluoride. So the central atom would be boron. Now we have 3 fluorines here. After that, the atomic number is 5. The electronic configuration is 2s2, 1s2, 2s2, 2p. Now here 2p1 is given. Now according to the excited form, it is 1s2, 2s2, 2px and 2py. After that, the number of active set is 3. The nature of active set is bond pair. The hybrid orbital is sp2 as we have 1s and 2p. The shape would be trigonal because we have sp2 and in the sp2 always we have the trigonal shape. The nature or repulsion is bond pair repulsion and the angle between is 120. There is no lone pair. And that's all about these molecules. So by this formation or by this method, you can be able to take all the information about a single molecule. And that's all about today's lecture.